Once the prediction is wrong, for example, at the integer execution E stage, we get to know what's the real value, what's the actual result of the prediction after after the R stage at the E stage, right? And if we realize it's a misprediction, then all those prefetched instructions will be queued at the different stages. So attention, after the R stage, we will know the true branch direction, the actual direction. And the DLP, and firstly we discussed the superscalar. Superscalar is at each clock cycle, we can do the multiple instruction fetching, decoding, execution, and the write back. And for the data flow here, we introduce the definition of the data flow machine. And we have the basic data flow nodes to design a program. And one of the exercises is given the code, which to be able to design the corresponding the data flow graph for this code. And next one is the very long instruction word. The very long instruction word will pack multiple instructions or operations into one word or one instruction. So the VRW processors, each instruction is very, very long, including multiple instructions. And different from the superscalar, and for each time, it will only fetch one instruction, decode one instruction, but this one instruction will include multiple operations here. And for the write back, it will write back one instruction at each clock cycle. Here is a comparison between the CISC, RISC, and VRW. And one significant aspect we should pay attention is the register. For the CISC, it has a few and a proper specific register. For the RISC and VRW, it will have many and general purpose registers. The last one is the vector processor and the SIMD processing. And in the SIMD processing, we introduce two kinds of design. One is array processor, the other is a vector processor. For the array processors, at the same time, it will have the same operations. And at the same location, and it will have different operations, which is opposite to the vector processor. For the vector processor, at each fixed time, we will have different operations, and at each time, it will have different operations. But as for the same locations, we will have the same operation. So they are different. And right now, because of the scalability, the vector processor has been widely used. So those are the all reviews for our final. And in fact, all the answers we have been discussed already. And not the direct answer, but all the concept of questions in the final we have developed. So I would suggest everyone pay special attention to the slides we reviewed today, and as well as our homework. Okay, so that's all for today. And if you have questions,